Okay, so welcome to the part 3 of our video lecture for BJT. Okay, so now we'll discuss about the modes of BJT operation. So if you notice here, meron po tayong 4 modes of operation for your BJT. Okay, and so far, by the way, itong mga mode na to is determined by kung paano mo binabias yung iyong junction. Kasi di po ba meron tayong dalawang junction, yung CB at saka BE. So, if reverse bias ko si CB, reverse bias ko din si BE, ibig sabihin nasa cut-off ako. Kapag ka naka-forward si CB, naka-reverse si BE, ibig sabihin inverted yon. Inverted because kabaliktaran siya nitong ating active or linear mode wherein naka-reverse si CB and naka-forward si BE. Okay? Di po ba ito yung palagi kong ine-emphasize during the lectures na kailangan if we want our transistor to operate properly or nasa linear siya or active siya or on siya, yung term ko, dapat, 'di ba? Si BE is naka-forward. BE i-forward. Di po ba sabi ko ganun? And si CB naka-reverse. Okay? We also have saturation. If both of them naka-forward bias, then that is in saturation. Yung transistor natin is operating at saturation rather. Sorry. And so far, ito pala yung nako-consider natin. Okay? So just have it on your mind that we have different modes of operation for our BJT. Meron tayong active or linear, cut-off, saturation, and inverted. But in some book, you will not find this inverted. Itong tatlo lang yung makikita mo. Okay, so we have this graph. So on this graph, you can see meron tayong VCE on your x-axis, IC on your y-axis. And this one is our IB. Mga IB values po ito. Okay? Now, kung makikita mo, how do we interpret this one? So, this is our cutoff region. Okay? Yung cutoff region natin, say for example, yung IB mo, kapag ka yung IB mo is 0, although in-increase mo ng in-increase yung VCE hanggang sa breakdown, yung ating IC is napakaliit lang. Okay, kasi 'di ba, transistor is used as switch and amplifier. We want to amplify our IC. Kasi itong IC kasi, this is the output and your IB, it's like your input. Okay? So we want to amplify our IC. Okay? Now in this case, kapag kayong IB mo is 0, yung IC mo is napakaliit. Pag sinabi mo amplify, increase in value. So napakaliit ng IC, so ibig sabihin, we cannot amplify our current. Okay. Now, if we increase our IB from 0, gawin natin 50 microampere. By the way, how do we increase IB? Siguro in-increase natin yung VBB or what. Okay? Say, for example, in-increase mo yung VBB, in-increase mo, of course, correspondingly, nag-increase din yung IB into 50 microampere. So, notice na kapag 50 microampere ka, mas greater na po yung iyong IC. Mas malaki na din siya correspondingly. If we use 100 microampere as IB, greater din yung iyong IC correspondingly. Okay? So, how do we, this is determined by your beta. Your beta, di ba, that is the current gain, that is your IC over IB. Yung ratio mo yun. Okay? Kumbaga, yung output mo over the input. Now, say for example, andito tayo at certain value of CE. Okay? This is called the active region or linear. Okay? Ibig sabihin ano to, more like stable yung ating operation ng ating BJT. Kasi if andito ka, say for example, this level of VCE, pag bumaba ka, your IC is still constant. Okay? Or somehow stable siya. Bumaba ka ng bumaba, stable siya. But until such time, but merong time or values na VCE, which we will call the VK, usually that is if less than 0.7 na siya, pagka bumaba doon sa 0.7 yung value ng iyong VCE, usually, andito na siya. Liliit na yung value ng IC mo correspondingly. Okay? And this is called our saturation region. Okay, ito yung saturation region, this is the active region, and our cutoff region. Okay, so in this example, pinakita niya lang, meron siyang binigay na value for IC, which is galing lang naman to sa formula ng iyong IB, beta. So, ayun, naka-table siya, and then pinlat mo. Pinakita niya lang dito that this graph is true. Okay, that using this circuit, if you that if you tabulate the results using different IB yung ginamit mo, if you tabulate the result, you're gonna derive the same graph. Okay? So, ibig sabihin yung iyong transistor really behaves in this way. Okay? So, meron ka ding cut-off. Of course, cut-off natin is when IB is equal to 0. Now, if you look at this, of course, if this is open circuit, wala kang supply ng VBB, walang magpupush ng current dito sa ating base, walang IB. IB is 0. And when IB is 0, automatically, we do not have IC. Okay? More like IC is approximately equal to 0. Pero again, meron din siyang konti because of some impurities or temperature and a lot of factors. Okay? But ideally, 0 ito. Kaya tawag natin doon is cut off. Okay, so now gusto ko lang kayong i-introduce dun sa different names ng ating BJT configurations. Okay? So meron tayo, kumbaga, kung ganito yung arrangement ng ating circuit employing BJT, meron siyang certain na tawag. Okay? Now, we'll start with the common base configuration. Kapag ka ganito yung ating arrangement ng ating um, BJT or ng ating circuit, this is called common base. Bakit common base? Kasi di po ba andito yung base? Okay? Andito yung IC, and dito yung IE. So, kumbaga yung base natin is common siya both sa iyong input and yung output part of your circuit. So, ang tawag sa kanya is common base. Ito naman ganitong configuration class is called common emitter configuration. Kasi, yung emitter mo, both connected sa kanya si collector and yung which is our output side, and your base, which is more like our input side, or input and output terminals, both nakakonect sa kanya. So, common emitter ang tawag natin dyan. Ito namang isa class, this is called the common collector configuration. Common collector because if you notice sa ating circuit, if this is our collector, both are common, or nakakonect sa kanya yung ating input terminal dito sa base and your output terminal dito sa ating dito sa collector. Okay, so sa book class, kung i-open niyo yung book, napakaraming circuit doon, ano? So, i-go over lang natin siya and then i-partly discuss lang natin and then it's up to you if you wanna really solve them. Okay, doon sa book, which I would suggest you would. Okay, now, say for example, meron kang problem na ganito. Ano ba to? This is capacitor class. Okay, so si capacitor, kapag itong mga BJT circuits kasi natin, meron siyang AC at saka DC analysis. What we're doing now is the DC analysis. So later part of the book, sa later part of our subject, we'll be doing the AC analysis. But since nasa DC analysis pa tayo, ang nangyayari kasi sa capacitor, kapag ka DC yung supply natin, is nag-open circuit siya. So parang wala lang to. Okay, wag lang kayong matakot dito. Okay, basta pag DC, ano ba yan? Ba't naka-highlight? Basta pag nasa siya, DC analysis, as if wala ito. Ba't naka-highlight? Wait. Yeah. As if wala ito. Okay, so disregard. And if you notice, dito, as if meron tayong, unlike sa previous natin na nasolve na meron tayong VCC at saka VBB, this one, isa lang yung ating voltage supply. So, baka malito ka, pwede din naman na you replace this one with this one. Para as if meron po tayong dalawang um, independent na supply dito. Pwede naman yon. Okay? So, still ganun pa rin. Yung RB, yung RC mo, andyan pa rin siya. Hiniwalay mo lang yung ating voltage supply dito. Pwede naman siya for analysis purposes only. Okay? But kung in reality, since isang voltage supply lang to, alangan naman i-split mo sa dalawa. 'Di ba? So, para lang ma-solve mo lang siya ng maayos, no, ma-analyze mo siya ng maayos, you can, as if, ihiwalay mo siya. Okay? Same value. Equivalent lang yan, class. Alright? And pwede kang mag-loop. Yung same sa example natin, pwede kang mag-loop on this side. This is called the base emitter loop kasi dumaan po tayo sa base and sa emitter. This is called the base emitter loop. Kapag ka dito ka nag-loop, this is called the pwedeng emitter collector loop, collector to emitter loop, ganun. Okay? Ayan. So, ito na yung ating um, collector-emitter loop. Okay? So, pag sinundan nyo yung book, if you notice, ang dami niyang formula, ano, kasi ang approach niya dito, different configurations or kumbaga different circuits, dinerive niya yung mga formula, which I would not suggest kasi alangan naman identify mo pa yung configuration, kung anong klaseng circuit to, and then recall the formula. No, wag nang ganun, okay? Basta alam mo lang yung KVL, yung mesh natin, yung looping natin, yung Ohm's law, and yung um, yung rules and how do we analyze BJT, no need to no need to memorize these things na. Okay? Basta alam mo lang kung saan pwedeng mag-loop, okay ka na. You're good to go kahit di mo na i-memorize. Okay? And, ano ba to? Okay, meron siyang mga examples. You can solve this one if you want, but, which I would suggest you solve. So, meron din tayo dito ang emitter stabilized bias circuit. Emitter stabilized po kapag ka meron siyang, meron kang RE. Usually kasi wala dito, di ba? Pagka meron kang RE, ang tawag natin sa circuit na yan is emitter stabilized bias circuit. So, ang goal ng ating resistor po dito o yung IE is to stabilize or increase stability sa ating circuit. So, kapag sinolve mo naman to, the same pa rin naman, ano, pwede mong ihiwalay itong VCC para mas madali. Disregard mo tong capacitor dito or tanggalin mo para hindi ka malito. And then, do the loop. Pwede kang mag-loop sa ating base emitter. Pwede ka rin sa collector emitter. Okay? Depende kung saan applicable. Just like here, nag-loop siya dito, dinerive niya yung formula. Which, again, it's okay na to really memorize this. Basta alam mo lang kung ano yung mga dinaanan niya dito at saan pwedeng dumaan. So what I'm doing now, is I'm doing parang ina-scan ko lang yung book para pag nagbasa kayo, more or less, na prime na kayo. Because, honestly, we cannot really go over into this by detail. Kayo nang bahala to practice using the examples sa book. So this one, if naka-encounter ka ng ganitong circuit, again, kasi DC analysis tayo, you can just disregard the capacitor first because DC pa, and then hiwalay mo lang to, and then you simply do the loop. And there are problems which would require you to look for your IC saturation. Okay? Kumbaga, ano ba yung value ng IC na pinaka-saturated na? So to do that, simply set nyo lang yung VCE into 0, and then yung previous na natin na ginagawa. Okay, solve mo lang yung IC mo using the same process before. It's just that tatandaan mo that your VCE is set it to 0. Isa pang pinaka-common na configuration for your BJT is itong ating voltage divider bias. Sa voltage divider bias, ganito po yung itsura niya. Okay, what's new? So, meron ka pa rin RC, meron kang RE, pero, okay, so pagka ganito, again, ihiwalay mo tong VCC. No, kung titingnan mo, meron ka ng dalawang resistor dito sa iyong base. Parang may ganito ka na. Okay, so this one, kapag draw mo siya, ganito yung magiging itsura niya. Now, unlike before na meron ka lang isang resistor dito, walang R2, ngayon may R2 na. Kapag ka ganito, okay, this is called voltage divider. How do we do that? There are two ways to do that. First is yung tinatawag natin na exact analysis, and yung isa is yung tinatawag natin na approximate analysis. So, sa exact analysis, kasi kapag ka ganito yung ating circuit, pwede nating i-transform into Thevenin. Okay, hanapin mo yung RTH, tsaka yung VTH, or ETH, and then you replace it with the corresponding one. So from here, papalitan po natin siya ng ganito. Paano ba? So, ang process nito is the same lang nung sa ating circuits. Okay, I will introduce this on circuit. So, abangan nyo na lang doon and i-apply nyo siya dito. Okay, so from here, once nakuha na natin yung ating ETH and RTH, nagiging yung normal na lang siya na sinosolve natin, di ba? Pwede na tayong mag-loop dito. Kasi, in here, ang problem kasi dito, pag nag-loop ka dito, mahirapan kang mas complicated siya because yung IB natin, take note, is hindi itong current that flows through our R1 or R2, kundi itong andito, pinaka-IB natin. So, medyo mas mahihirapan ka na because there are a lot of currents na involved na. So, sa exact analysis, ang approach niya is to replace this one with our Thevenin equivalent circuit, which is this one, and then you proceed with the normal na nating solution. Yung isa is the approximate. Okay, so sa approximate, ina-approximate natin na itong IB dito is approximately zero siya. So kapag walang current dito, um, yung ating R1 and R2 nagiging series. Okay, so pwede mo na lang siyang i-add and then you proceed with yung normal na. Pero, that is only applicable, mag-approximate analysis lang tayo if we satisfy this condition. If our beta RE is greater than or equal to 10 R2. Okay, yung beta, alam niyo na to. Ang RE, alam niyo din to. Itong R2, take note na ito yung, andito. Okay? Ito yung R2. This is R1, R2. Kailangan masatisfy muna ito that your beta R is greater than or equal to 10 R2. If this is true, then we can proceed with our approximate analysis. Okay? So approximate analysis, kumbaga, we are accepting that IB is equal to 0. So kapag ka 0 to, our I1 now is equal to I2 again. So series na to. So you can now combine this one. Okay? So if this is our voltage divider circuit, and say for example, na satisfy natin that your beta RE is greater than or equal to 10 R2, ito yung R2, so pwede na, so ihiwalay natin at itong ating 22 volts, okay? Pwede na natin i-series ngayon or i-combine itong 39 k ohm with 3.10 k ohm. Pag na-combine na natin yon, so magiging, yeah, yung previous circuit, parang ganun na din yung ating calculation. Na-simplify na siya. Okay? But again, that is only applicable kung nasatisfy yung previous na sinabi kong condition. So just like here sa example na to, basahin nyo na lang ha. Nasatisfy, kasi yung una niya sinolve is if, tinest niya muna if your beta RE is equal to greater than or equal to 10 R2. Okay? Kasi sinolve niya, nakakuha siya ng 10 kilo ohms. It is greater than 39 kilo ohm na satisfied. Then, pwede na siya mag-proceed into approximate solution. Meron din po tayong circuit na ganito. Okay, huwag kayong ma-shock. Ang tawag natin dito is um, uh, voltage. This has voltage feedback. Okay, merong feedback, which is itong RB na to. Okay, this DC bias with voltage feedback, this is again for improved level of stability para mas stabilize lang yung ating circuit. Yun yung purpose ng ating RB dito. And how do we solve this one? Ganun pa din naman ano, just remember lang din kung saan ka pwedeng mag-loop. So, pagka ganito, we can draw this one as this. Tama po ba? Tanggalin muna itong capacitor. Itong VCC, pwede din naman siyang i-draw na pag ganito. So, ang gagawin mo, pwede ka lang mag-loop from here. Pwede ka dito. Loop. Okay? You can also do looping here. So, meron kang voltage across this resistor and yung iyong junction voltage dito, which is your VCB. And pwede ka ding mag-loop dito sa labas. Okay? Applicable pa din lahat yun. But take note na yung pinaka-IC mo lang is itong pumapasok dito sa collector terminal na to. This is not IC anymore. Itong RC natin, yung current na pumapasok sa kanya, hindi na yung IC. Okay? That is IC prime. Yung pinaka-IC, eto na. Okay, kasi yung pumapasok na current dito sa yung resistor is nade-divide pa siya into dalawa according to our KCL. And yung ating IB is ito pa rin kasi siya lang naman yung pumapasok dito. Still, this is your IE. So, meron kang IC prime. We'll call this IC prime kasi hindi naman talaga ito yung IC. Ang IC prime natin therefore is equal to IC plus IB. Okay? So, I will try to situate, I will try, try ko lang ha, para sa doon sa lahat na mention ko na additional na configuration ng ating transistor, makabigay ako ng example. Okay? But as of this week, ang pinaka topic natin is itong BJT. Lahat sa BJT. Kasi next week, more like mag-FET na tayo or field effect transistor. Kasi diba remember, there are two types of transistor, BJT and field effect transistor. So next week, dun tayo sa FET. Okay? So, most probably, dapat yung goal nyo for this week is ma-solve nyo itong mga examples dito sa book. So, wag na lang kayong masyadong umasa sa mga examples ko, ano. Meron naman kayong mga books diyan, binibigyan ko naman kayo ng resources. After niyo mapanood tong more like lecture ko, you solve on your own. Okay? Kapag ka may tanong, yeah, pwede na kayong magtanong sa akin. Pero as much as possible, you solve on your own. Okay, so hanggang doon lang tayo. Um, yung pinaka pag-aaralan nyo is yung uh, calculations or yung solutions, problem solvings rather, employing different BJT configurations natin. Kasi sa finals, this would be purely ano lang, purely problem solving, wala na tayong multiple choice. And again, sa finals natin, that would be held sa, I think, gymnasium. Yung inyong circuit at saka electronics is sa gym siya. Announce ko na lang for your, ano ba tong ECE 171. Ito yung electronics. Yung electronics natin ay sa December 16, that is 2 p.m. sa ATD Court. At ang iyong circuits ay sa December 17, that is 10:30 a.m. sa room 203. Ayun. So, on-site po yung ating final exam. So, no one else will help you but yourself. So, please just study on your own. Anyways, you have your book. I promise you, pag kasi nandun nyo lang yung book nyo, wala kayong problema. Okay? And, yeah, yun na. Yun na nga. So, I will just try to, again, yung sabi ko kanina, I will just try to upload examples of solving different BJT circuits or configurations, yung mga na-discuss ko. Okay? But I cannot really promise. Basta mapapromise ko lang is pag may question kayo, you just PM me and I will just assist you. Okay? So that's it for this video lecture and keep safe.